All right, so here we are, Chapter 1, Environmental Science 20, Section 1.2. It's a short section here, but let's talk about a few things. You have your notes in front of you with some blanks there, so please fill in the blanks as we move along. So environmentalism. Okay, so we talked a little bit in the intro about the difference between environmental science and environmentalism. Now, no judgments here. This is just sort of what some of the observations are, feelings about the difference as well. So environmentalism is different than environmental science, as we mentioned. Environmentalism is often seen as rather extreme, okay? They usually try and make a big splash, right? Pardon the pun, in the case of Greenpeace, we just talked about Greenpeace, right? They try and do something that's a little bit more extreme than normal people would do to get attention. Radical, some people would say that they're a little radical, okay, very passionate and kind of go to a little bit of radical extremes in their actions. And they're they focus on very specific issues. Well, actually, the specific issues are difficult to identify. So it's kind of almost like a large scale, we're standing up for, against climate change. So the actual specific maybe issue is sometimes hard to identify. So that's sort of the difference. Environmental science, we focus on specific things and we try to be objective. So that's the kind of the difference. Environmentalism is passion oriented a lot of times. So this class tackles specific issues and problems and possible solutions from a scientific perspective. Now, everybody has their biases, right? So we all feel a certain way about certain things, even in environmental science. So we are not free from our biases, and even if you feel very strongly about environmentalism and you think, no, this is a very objective, it's very science-based, it's, activism in this way is a very objective science-based thing. So you might have a bias towards that, whereas someone might say, oh, they're all crazy, right? They're radical crazy people. So we try to be as objective as possible here in this class anyways. And we'll talk, and as we share our thoughts and ideas about things, we will, do our best to have respect for someone else's opinion. And so there will be times where you will share your thoughts on certain things. Do you have these notes in front of you? Yeah, okay. Good, maybe just close your Chromebook for now. You need that right now. It's okay to be passionate about the environment, and doing our part is certainly easier when we are informed, okay? So that's what this class is all about. I want you guys to be informed about specific issues. Okay, the Industrial Revolution was an important part of human history in the 1700s and 1800s. During this time, many new mechanical inventions made production of materials and the advancement of technology much easier. So the mechanical inventions in the Industrial Revolution. Machines that could do jobs that took, humans many hours or days or weeks to do, machines could do them in a matter of seconds, right? And we know about technology, how scientific principles and mechanical inventions are all kind of come together, and now in our phones and smartwatches and different things like that are fairly complex. There's a lot of processing, a lot of operations that can happen in a very short and a very small amount of time and space. So this time in the Industrial Revolution is where waste and pollution became a real problem. So making of the machines and the waste that the machines themselves ended up producing, even as far as the gases they produce, the exhaust from engines, not to mention the because everything was being built on such a large scale that the waste from the building process started to pile up really quickly. Scientists have discovered the law of conservation of mass, which means that everything that is created comes from something else. Nothing new can be generated without using something else and changing it indefinitely. So when you create something new, it doesn't come out of thin air. It always comes from something, some parent material. That's the law of conservation of mass. Also, for waste and pollution, everyday things break down into smaller other things which are sometimes harmful. Okay, so if you're trying to build something, you need to take pieces of something else to combine to build something. But also, if things start to break down, they become other things. They don't just disappear. And that's the waste and pollution problem, right? If there are certain chemicals that are a byproduct of some kind of process, and those chemicals that are maybe from a breakdown of something, if they just get emitted into the river or something like that, they don't just disappear. They go somewhere. Now, we try to put waste somewhere where it's not going to bother anybody or anything. That's what we try and do, right? We have a landfill. We have a big hill at the north end of the city there, right, where we dump all the garbage. We dig a big hole, we dump it in, we fill it up, all this sort of stuff. So we're trying to put it in a space where it doesn't bother people or affect too much. And also, if there's something good that can come out of these waste places, then that's great too, which we'll do a little bit of research on our landfill. Yeah, you'll find out a little bit more about the landfill here in the city. And just a final note, nothing comes from nothing. Okay, so when something new is created, it comes from other things. So if we were making technology, if we're making our phones, you guys mentioned, deep sea mining and things like that. With the increased demand for all this technology, there are rare earth metals that are required for this technology, and so they have to come from somewhere. And so there's big, large-scale processes that extract these little tiny bits of metal that are required in some of our technology. So that's the thing. People are like, yeah, phones are great. Well, they are kind of great. They help us with a lot of things. But what's the cost? There's a lot of cost involved. And it's not just money. It's sometimes nature. It's sometimes the process of getting those pieces and putting them together generates other problems. Okay, so there's another law. It's called the law of conservation of energy. It's similar to the law of conservation of mass. It says that everything that takes energy uses energy from another source. So anything that does any work, anything that requires any heat or any propulsion in any way, even our bodies, right? In order to exert energy doing anything, like even talking and moving right now, my body needs to get energy from somewhere to do that, right? And so we eat every day. And the food that we ingest actually breaks down and releases energy inside our body, and our muscles and brain uses that energy. So if you can go without food for a little while, there are energy stores in your body, like in the fat molecules and stuff, and you can not take in energy, and your body can say, hey, where is the food that we normally get? Oh, okay, I'll have to go to the back here and grab some of this energy that I have stored in the fat, and that's how you lose weight. That's how you lose fat. If you're on a diet or something like that and you work out, you don't eat as many calories, you get your body to use up its own fat stores, the energy storage. So that's kind of how you lose weight. Oh, you're losing weight. What are you doing? Well, I'm working out, so I'm expending more energy and I'm taking in less energy. So that means that all the fat, like I got a bunch right here, all this, I wish I could just use this and be more energetic because I'm really tired right now. But you know what I mean? Like your body, through a rather complicated process, will extract that energy from the storage that you have. And so, on the other hand, right, as you know, I mean, you guys know this, but if you take in a lot of energy and your body can't use it up because you're not exercising or you're not using it up, then your body says, hey, we got all this extra energy, what do we do with it? I don't know, put it in the back. So it stores it, and that's how it stores as fat. That's what it is. So it's kind of like it's retrieval, store. You can go and get some more energy if we need it. Sometimes it's just hard to get that energy out. Plus, when we keep eating and keep taking in all this energy, it doesn't need to touch the fat in the back room. It just uses all the energy from the food that you're consuming. So, anyways, what do we got to say here? Non-renewable energy, and this is a big focus: renewable and non-renewable energy. But non-renewable energy can never be used again. So it's kind of like a one-time shot. Fossil fuels, once you burn gasoline in your vehicle, you can't get that gasoline back. You know what I mean? It's not like you can use it and then wash it up and then use it again, right? It's non-renewable. There is renewable energy, and that comes in the form of wind energy, solar energy, hydropower. These are not one-time use types of energies, and we call them renewable energy. So we will study these in more detail upcoming. We'll do a little more research on these kind of energy sources. Sustainability is the term that we use, and it's a balance of energy and matter consumption. So with responsible production, we can balance, the energy and matter that we use. So to be sustainable, we don't use more than we need, and we kind of produce in accordance with what we use, and we don't get too out of balance there. It is a cycle, sustainability, that is able to be sustained indefinitely. And that's kind of the goal for our material consumption and for our energy consumption, is to try to get to a sustainable paradigm or sustainable plan. A paradigm is sort of a worldview, an action, a structure that we work within. And so if we can have some kind of sustainability, then that's kind of a goal that we have. And I say we as in, like, governments and countries and many people realize that we need to be good stewards of our environment. So it should be the goal of proper stewardship of our environment, not using excessive amounts of things to produce excessive amounts of waste. This is where the notion of recycling comes in. So you've all heard of recycling, right? If we can reuse things like now the shopping bags, right? No more plastic shopping bags. It's the reusable cloth bags, right? So the ones that I always forget to take into the store still. When I get to the store, it's like, oh, the bags are in the van. Get all these groceries, like, oh man. So that's a movement to becoming more sustainable, right? Not producing all this sort of. Now the plastic bags, right? Most people, I think, reuse the plastic bags as much as possible. So the grocery ones, I know we would kind of tie up the plastic bags and throw them in a bucket or whatever under the sink. And then when we needed to use them for garbage or whatever, we would at least use them at least twice for different things, right? Like most people, I think, would. But still, even for a plastic bag that takes many, many years to degrade, like many, many, many years, it sticks around for a long time. So even to use it twice, that's a lot of waste, right? Even using things twice. So, like some of you have a lot of you have water bottles here. Like the plastic ones that you throw away, or like kind of the plastic water bottles, those are made from recycled materials a lot of times. So in a sense, even though you're using it once and tossing it in the recycling bin, those materials can be regenerated a little bit, but many of you I see have water bottles, and so you just reuse those water bottles, and that's a good way of recycling. Also to use more renewable energy sources when possible, so we don't use up the one-time energy too quickly, that we have around us. So in our lives, there are one-time energy uses that we use all the time, but if we can find ways of using more renewable energy and not use up this one-time energy at least too quickly, we can be, far more responsible. Okay, I'll pause there. Do you guys have any questions or comments about any of this stuff so far? Yeah.
I have a question on law of conservation of mass.
Yeah.
And the law of conservation of energy.
Okay, the laws. Yeah.
Yeah, I was thinking like if there's a nuclear reaction, that means that we have less mass and more energy.
That's right.
So
yeah.
they are not conservation.
Well, mass is mass. So here's the thing: there's a connection between mass and energy.
Yeah.
And that was the big thing that Einstein figured out. So in every other process other than nuclear processes, it's fairly straightforward. There's two categories. So matter comes from matter when we're talking about regular chemical processes, and energy comes from energy when we're talking about regular energetic processes. The big thing about Einstein, E equals mc squared, is energy in some way is equal to mass. So there is a connection at the top, but it's only it's at a very small and difficult to get to level. So yes, the E equals mc squared does connect these two laws together, but yeah, that's 99.99% of everything that happens is not that. So, any other questions? All right. Okay. So, all right. So this is what we're going to be doing here now. We're going to be moving towards an assignment called an ecological footprint lab, and this is going to involve you going to a website and answering a bunch of questions about your sort of lifestyle, like how often you use a recycled water bottle, or how far you have to drive to school, and do you carpool, and do you grow your own food in your garden, and stuff like that. So what this is going to do is to help us sort of understand, and I did all this just recently. I found this and did it all, made up the questions, and it actually is quite enlightening. It's quite eye-opening. And you get to compare your ecological footprint with the average ecological footprint for other people in the world. And you can actually see data from other countries. And so you could kind of see if your lifestyle would fit in a different country. And that's kind of cool. So it's called the Ecological Footprint Lab. This website, this link is also on my website. So if you look up courses, Environmental Science 20 on MrMathWell.com, you will see down here somewhere. Let's see if I can find it for you. Oh, there's some videos, there's some notes. Here we go. Ecological Footprint Lab. This is the Ecological Footprint Calculator website. Here is the student lab question form, which I believe I have some here to hand out to you. But it's also, you can also get the document online. Now, if you want to submit a digital form of this, I would be okay with that. So I will give print copies to whoever wants it, but it is all here on the website. So we're going to take the rest of this class and possibly a bit of tomorrow's class as well to do this lab. So go ahead and get a start on that. But that was the conclusion of section 1.2.